Hello, thanks for clicking. Welcome to another Margulis 2 production. Today we're going to learn how to work in the polar coordinate system. So, for most of your mathematical lives, you worked in the rectangular coordinate system, right? X comma Y. Now we're going to learn to work in the polar coordinate system, which is definitely a little bit different. It looks different. But let's talk about how to graph some points, how to convert back and forth between one system and the other, and we'll get a chance to get a brief overview of the system today. All right, so let's get started. So, I already got started. The rectangular coordinate system looks like this. This is the one you're known and used to, right? So points are x comma y in ordered pair form, and then y is equal to f of x. So y is usually written in terms of x. So for example, if I ask you to graph the point 2, 1, you go 2 spaces to the right, 1 space up, and make a point. And that would be it. And you can do this with any number of points. You can connect the points to make functions if you'd like, and then write equations for them. So the rectangular coordinate system is the one that you've been using for a very long points in your mathematical career. But today, what we want to do is we want to talk about the polar coordinate system. So this is the graph of a polar coordinate system. The polar coordinate system writes r in terms of theta. R represents the radius, okay? And points in the polar coordinate system are written as r comma theta. The radius first, the angle theta second, all right? So let's talk about how to plot some points. Let's try to plot a point below here. So r, just so we know, is the distance from the origin, or what is considered to be the pole in polar coordinate system, all right, to a radius of this length. So for example, if you look, you can see these little circles that surround our system here. So a point out here would have a radius of 1. A point out here would have a radius of 2. A point out here would have a radius of 3. Okay, and you can have more concentric circles, radius 4 and radius 5. The further you go out, this is how much I could fit on the slide today. So that's what we're going to work with. All right, and then you have angles starting from 0 and moving counterclockwise, just like you did with your unit circle, right, all the way around up to 2 pi, which is really just 0. They're in the same place. All right, so if I say, pi over 3, then you're going to draw this way toward pi over 3 at whatever radius. If I want 5 pi over 6, you're going to draw your point this direction at whatever radius I ask you to draw. Okay? All right, so let's get started. We'll give this a shot. It takes a little getting used to, but it's not too terribly difficult, I hope. So letter A, I want to graph or plot the points 1 comma 5 pi over 4, which means the radius is going to be 1, and theta, I'm going to draw that point at the angle 5 pi over 4. Okay, so I need to find my angle first. Basically what I'm doing is my x-axis here, I'm going to draw in standard position. And then I'm going to draw 5 pi over 4. Let's find 5 pi over 4. 5 pi over 4 is here, this angle between 7 pi over 6 and 4 pi over 3. And I'm going to draw out to a radius of 1. So out to a radius of 1. And that's where my point A would go. Okay? So again, it's at this angle, around this way, at the radius of 1. All right? Okay, let's try point B. So now we'll do it in a different color. So now r is equal to 2, and theta is negative 2 pi over 3. Okay, so what does it mean for theta to be negative 2 pi over 3? So that means, again, I'm going to start here, standard position. 2 pi, negative 2 pi over 3 means I'm going to go clockwise around this circle 2 pi over 3 units. So to go clockwise at an angle of 2 pi over 3, that would put me at 4 pi over 3, right? If I'm at negative 2 pi over 3, that's where I want to go. So I want to go clockwise 2 pi over 3. That puts me at 4 pi over 3. That's my angle, and my radius is 2. So I'm going to go out 2 units at 4 pi over 3. That's B. Okay. Now, the one that's a little bit really different here is C. So in C, the radius is negative 3, and theta is 3 pi over 4. All right, so again, standard position. There it is. Now, you're probably saying to yourself, well, wait, R represents the radius of that circle, but the radius can't be negative on a circle, and you'd be correct. It can't be negative, okay? And theta is 3 pi over 4. So 3 pi over 4 is in the middle of quadrant 2 up here. There's 3 pi over 4, so I'm going to go out to this angle. But the radius is negative 3. So normally I'd come out to here. That would be a radius of 3. But the radius is negative 3, which means that I'm actually going to go in the other direction that the angle is telling me. So the angle is telling me to go out this way to 3. Since radius is negative, I'm actually going to go out the other direction to 3 and make my value of C there. Okay, so when the radius is negative, you go the opposite direction as you would if the radius were positive. All right, that's how you plot points in polar coordinates. Okay, all right, so now let's talk about how to convert. So we're going to convert from rectangular to polar and polar to rectangular. So it's actually not as difficult as you would think to do that. Remember, rectangular coordinates have the coordinates x comma y, and polar coordinates are in r comma theta. I want to figure out a way to get back and forth between the two. Okay, so let's start by going from, let's say, x comma y to r comma theta. So we're going to go from rectangular to polar. So that means I'm given a coordinate with an x coordinate and a y coordinate, and I need to convert it to r and theta. So you actually know how to do this, all right? Because if you look at your circle and come out this way, down here, here's a point x comma y. You have, well, this distance across here is x, this distance here is y, and that's the radius. But this is a right angle, so I could use the Pythagorean theorem. X squared plus y squared equals r squared, right? If I have x and y and I substitute them in, it would tell me what r is equal to. Okay? And now, how do I find theta, though? Well, here's the angle theta there. So theta, in terms of x and y, is y divided by x. Y over x would be tangent. So tan theta, oops, let's write it over here underneath. So tangent of theta would be y divided by x, which means theta is equal to the inverse tan, or arctangent, of y over x. So if I know what y is and I know what x is, and I take the inverse tan and find the angle for this ratio, he would tell me theta. And then I'd have a point with a radius and an angle theta. So I'd take this point and convert it to polar. Okay? All right, so now let's go from r comma theta to x comma y, from polar to rectangular. And I think, honestly, that's actually even easier because you know r and theta, you want an x and a y. Well, I know a couple of things. I know that the cosine of theta is equal to x over r, which means if I solve this, x is equal to r cosine theta. And I know r and I know theta. So if I substitute them into this formula, it would tell me what the x coordinate would be. And then in the same breath, sine theta is y over r. So y is equal to r sine theta. So if I know r and theta, I can figure out y. So if I use these two equations, that would convert me to a point in rectangular coordinates. Okay, that's how you're going to convert back and forth between one system and the other when it comes to points. All right, so now let's actually go ahead and do that. So let's convert the point 3, 6, 3, pi over 6. Nah, we want to convert this to rectangular. Not polar, sorry, that's a typo. So we're going to convert the point, this is a polar point, to rectangular. We want to go from polar to rectangular. So polar has an r and a theta. We need to make it an x and a y. All right. So we're going to use our two equations that we have. So go from polar to rectangular. We know cosine theta is equal to x over r. So that means x is equal to r times cosine theta, right? Just multiply by r on both sides. So then x will be, well, we know r is 3 and theta is pi over 6. So x would be 3 cosine pi over 6. Cosine of pi over 6 is root 3 over 2. So the x coordinate will be 3 root 3 divided by 2. So 3 root 3 divided by 2. That's my x coordinate. Now I need the y coordinate to go with it. So to get the y coordinate, I know sine theta is equal to y over r. If I multiply by r on both sides, then y is equal to r sine theta. So y would be equal to 3 times sine pi over 6. So the sine of pi over 6 is 1/2. So y would be equal to 3 over 2, or 1.5. And that's how I convert from polar to rectangular. So this polar point, okay, is in the same place as 3 root 3 over 2, comma 3/2. All right, in the rectangular coordinate system. Okay, and finally, let's convert the rectangular coordinate, 1, -1, to polar coordinates. All right, so rectangular, so this is my x and y, and I want to make this an r theta. Okay, so to do that, first thing, I know x squared plus y squared equals r squared, the Pythagorean theorem, so that should be easy enough. We're going to substitute in 1 squared plus -1 squared equals r squared. So 1 and 1 make 2. So if I take the square root on both sides, I get r equals plus or minus square root 2. Okay, so plus or minus square root 2. All right, so we'll sort out that in a minute, the fact that it's plus or minus, and we'll see how that can work. All right, but now we also know that tangent theta is equal to y over x. So theta is just the inverse tangent of y over x. So theta would be the inverse tangent of -1 over 1. So that's the inverse tangent of -1. So what's the inverse tangent of -1? Okay, so there's a couple places where tangent is -1, right? Tangent is -1 on your unit circle in quadrants 2 and 4. So that would be 3 pi over 4 or 7 pi over 4, right? Or negative pi over 4 if you're using the proper notation. Okay, negative pi over 4 for inverse tan. All right, so I'm going to say 3 pi over 4. Well, technically my answer is negative pi over 4. So let's write it like that. We're talking about inverse tan, inverse tan. Lives in quadrants 1 and 4, but lives as a negative reference angle there. So negative pi over 4 is my answer. All right, so then how do I know whether it's plus square root 2 or minus square root 2? Well, first of all, 1, negative 1 is here in quadrant 4. So if I go an angle of negative pi over 4, that would mean I'd go to this here, right? From here down. So I would want to take just a straight shot from here down to there. So I would want to use root 2, the positive. So I just want to go out this way to that angle. Okay? I could also write this point as root 2 comma 7 pi over 4. So now you can see the interesting part here is you can write this point in multiple ways. So 1, negative 1 can be written in multiple ways, right? Because if I go all the way around to 7 pi over 4, that would take me here and then out to root 2. Yeah, that would be root 2, 7 pi over 4. I'd be in the same place, right? But what if r were negative? Well, negative root 2. How would I do that? Well, if r is negative, it means you go the opposite direction from the angle that they're asking. So if I want to end up over here, I would have to go, if r is negative, out there, right? I'd have to go out to here first so that I'd end up going in the opposite direction and end up at 7 pi over 4. So what's this angle up here in quadrant 2? That angle is 3 pi over 4. So if I were to go around to 3 pi over 4, we'll do it dashed, but now it's negative, I'd have to go out this direction for r, and that would put me back in the same place as these other 2 points. So here are 3 different points that all represent 1, negative 1 in polar coordinates. Okay? And that's where it starts to get a little bit tricky. All right? So this is a very brief introduction to polar coordinates. There's many other things that you can discuss. Okay? But as always, thanks for clicking.